You will survive 3 weeks without food. You will survive 3 days without water. And when the power goes out and the municipal water pumps stop running and the pipes freeze and burst and the taps go dry, you will have approximately 72 hours before dehydration begins, shutting down your kidneys, your brain, and your ability to make the decisions that keep you alive. That is the timeline. Not hypothetical, not dramatic, medical. The human body loses approximately 2.5 liters of water per day through breathing, sweating, and urination. Without replacement, blood volume drops, blood pressure falls, organ function deteriorates, cognitive function collapses. Within 72 hours, the average healthy adult enters a medical crisis that cannot be reversed by any amount of food, heat, light, or shelter. Water is not the most important survival resource. It is the only survival resource that has a 3-day deadline attached to it. And here is the part that should terrify every person watching this. During Hurricane Maria in 2017, Puerto Rico lost municipal water service for months, not days. During the Texas grid failure in February 2021, 14.9 million people lost water service simultaneously. During Hurricane Helene in 2024, entire communities in the Appalachian Mountains went weeks without running water. In every one of these events, people surrounded by rivers, streams, ponds, and rainwater could not drink any of it because they had no way to purify it. They stood next to thousands of gallons of water and were dying of thirst because nobody had ever taught them that the technology to make that water safe to drink has existed for 4,000 years, requires zero electricity, zero chemicals, zero manufactured filters, and can be built from 2 containers, prosthetics, and gravel for $2. The technology is called a biosand filter. It was formalized in 1991 by Dr. David Manns at the University of Calgary. But the principle behind its slow sand filtration was used by the ancient Egyptians, documented in Sanskrit medical texts from 2000 BC, deployed in the first municipal water treatment plant in Paisley, Scotland, in 1804, and is currently recognized by the World Health Organization, the United States EPA, and Oxfam as one of the most effective water purification methods ever developed. Over 200,000 biosand filters are in use worldwide, primarily in developing nations across 55 countries. They remove 90 to 99% of bacteria, up to 99% of protozoa, including Giardia and Cryptosporidium, and virtually all sediment and turbidity from any surface water source. They operate by gravity alone. They require no electricity, no fuel, no pump, no chemical additives, and no replacement cartridges. They last for decades. And the $20 billion water filter industry, which sells you a $30 Brita pitcher with $8 replacement cartridges every 2 months, a $350 Berkey gravity filter, or a $60 annual subscription to filter delivery services, has never once mentioned that the same purification can be achieved with sand, gravel, and a bucket. Welcome to Camping Secrets. If these stories matter to you, the subscribe button and the bell are the best way to make sure this knowledge survives. This is where we dig up what the industry buried. Now let me take you inside the sand. Because the mechanism by which a biosand filter purifies water is not simple physical straining. It is a living biological process so sophisticated that it outperforms most chemical treatment methods. And it was invented not by a scientist but by nature itself. When water passes slowly through a column of fine sand, 3 purification mechanisms occur simultaneously. The first is mechanical filtration. The pore spaces between sand grains are small enough to physically trap suspended particles, sediment, and larger microorganisms including protozoan cysts. Giardia cysts are 8 to 15 micrometers in diameter. Cryptosporidium oocysts are 4 to 6 micrometers. The effective pore size between fine sand grains is approximately 40 to 100 micrometers, but the tortuous pathways the water must follow through the sand column force particles to contact sand grains, where they are trapped by physical interception and adhesion. The sand does not just strain particles like a sieve, it catches them on surfaces through the winding path. The second mechanism is adsorption. Sand grains carry a mild electrostatic surface charge. Bacteria, viruses, and dissolved organic compounds in the water carry their own surface charges. As contaminated water passes over the charged sand surfaces, pathogens are attracted to and held against the grain surfaces by electrostatic forces, much the way dust is attracted to a charged balloon. The pathogens are physically removed from the water flow and held in place on the sand. The third mechanism is the one that makes a biosand filter fundamentally different from every manufactured filter on the market. It is biological predation. And this is the detail that the filter industry prays you never learn. Within the first 10 to 20 days of operation, a living biological layer forms on the top surface of the sand column. This layer is called the Schmutzdecke, a German word meaning dirt layer. It consists of bacteria, fungi, protozoa, rotifers, and aquatic insect larvae that colonize the sand surface naturally from organisms present in the water being filtered. This living biofilm does not just trap pathogens, it eats them. The predatory microorganisms in the Schmutzdecke consume bacteria, viruses, and organic matter as they pass through the biofilm layer. The pathogens that enter the filter as living threats exit as digested waste products of a biological community that feeds on contamination. The Schmutzdecke is a living immune system for your water. It self-maintains, it self-regenerates. It improves over time as the microbial community matures and diversifies. A biosand filter that has been operating for 2 months removes pathogens at significantly higher rates than a brand new filter, because the biological layer has had time to develop a more complex and aggressive predatory community. No manufactured filter does this. A Brita filter uses activated carbon to absorb chlorine taste and some dissolved compounds. It does not remove bacteria. It does not remove protozoa. It is designed for treated municipal water, not raw water sources. A Berkey filter uses proprietary media that must be replaced periodically. A UV sterilizer requires electricity. A chemical treatment requires tablets or liquid that must be purchased and resupplied. Every manufactured solution has a consumable component, a recurring cost, or a dependency on an external resource. A biosand filter requires sand and gravity. Both are free, both are everywhere, and neither runs out. If you have made it this far, you already know more about water microbiology and filtration science than 99% of emergency preparedness educators, the vast majority of filter company sales representatives, and every survival product website that sells you $300 gravity filters, without mentioning that the underlying technology can be built from a bucket and a pile of sand. Subscribe and share this with every person you know who lives in a region where hurricanes, floods, ice storms, or infrastructure failures have interrupted water service within the last decade. Now here is exactly how to build one from materials that cost under $2 and are available at any hardware store, construction site, or natural landscape. Step 1. Acquire 2 containers. The traditional biosand filter uses a single concrete or plastic container. For an emergency build, 2 5-gallon buckets work perfectly, one stacked on top of the other. The top bucket is the filter. The bottom bucket is the clean water collection vessel. Alternatively, 2 large clay pots, one nested inside the other, provide the same function with the added benefit that the drainage hole in the bottom of the upper pot serves as a natural outlet. Step 2. Prepare the outlet. Drill or punch a small hole near the bottom of the upper bucket, approximately 1/4 inch in diameter. Insert a short length of plastic tubing or a rigid straw. Seal around the tube with silicone, hot glue, or plumber's putty to prevent leaking around the fitting. This is the outlet through which filtered water will exit the filter by gravity and drip into the collection bucket below. Step 3. Add the gravel under drain layer. Place 2 inches of coarse gravel, stones approximately 6 to 12 millimeters in diameter, in the bottom of the upper bucket covering the outlet tube. This layer supports the sand above it and prevents sand from clogging the outlet. Step 4. Add the separation gravel layer. On top of the coarse gravel, add 2 inches of finer gravel, approximately 1 to 6 millimeters in diameter. This layer acts as a transition between the coarse underdrain and the fine sand filter above it, preventing the fine sand from migrating downward into the coarse gravel and blocking flow. Step 5. Add the sand filter column. This is the heart of the filter. Add 16 to 20 inches of fine sand on top of the separation gravel. The sand grain size is critical. Ideal sand is between 0.15 and 0.35 millimeters, roughly the texture of beach sand or concrete sand available at any hardware store. Do not use play sand, which is often too fine and impedes flow. Do not use coarse builder's sand, which is too large and allows pathogens to pass through. Concrete sand or masonry sand from a hardware store is typically the correct grain size. Step 6. Wash the sand before use. Place the sand in a bucket. Fill with clean water, stir vigorously, and pour off the cloudy water. Repeat until the rinse water runs clear. This removes silt, clay, and organic matter that would clog the filter prematurely. 3 to 5 rinse cycles are typically sufficient. Step 7. Add the diffuser plate. Place a flat perforated object on top of the sand surface to prevent the incoming water from disturbing the sand and the developing Schmutzdecke. A plastic plate with holes drilled in it, a perforated pot lid, or a piece of cloth stretched across the sand surface all work. The diffuser distributes the incoming water evenly across the sand surface, without disrupting the biological layer. Step 8. Place a lid on top of the filter to prevent contamination from dust, insects, and debris. Any cover that does not create an airtight seal works. The filter needs air exchange for the aerobic biological processes in the Schmutzdecke to function. Step 9. Commission the filter. Pour water through the filter daily for 10 to 20 days before relying on the filtered water for drinking. During this initial period, the Schmutzdecke is forming. The filter is improving its pathogen removal rate every day. For the first 2 weeks, use the filtered water for washing or non-drinking purposes. After the biological layer matures, the filter is producing water that meets WHO recreational water quality standards from any surface water source. Step 10. Operate the filter by pouring water into the top daily. The biosand filter works best when used every day, because the biological layer requires nutrients from the incoming water to survive. If the filter sits unused for more than a few days, the Schmutzdecke can die and will need to be re-established over another 10 to 20-day period. For continuous emergency use, pour water through once or twice daily. Total material cost: 2 buckets, $2 from a hardware store or free from a restaurant. Sand and gravel, free from a construction site, landscaping pile, riverbed, or $2 from a hardware store. Tubing, $1 or free from available materials. Total cost approximately $2 to $5 depending on material sourcing. I need to be completely honest with you about limitations. A biosand filter does not remove dissolved chemical contaminants. Pesticides, industrial chemicals, heavy metals like lead and arsenic, dissolved salts and fluoride pass through the sand without being removed. If your water source is contaminated by chemical runoff from agriculture or industrial sources, a biosand filter will not make it safe. It removes biological contamination, turbidity, and sediment. For chemical contamination, an activated charcoal post-filter is needed, which adds approximately $1 to $3 for a bag of activated charcoal added as an additional layer in the filter column between the sand and the gravel. The filter does not produce instant drinking water. It takes 10 to 20 days for the biological layer to mature to full effectiveness. In an acute emergency where clean water is needed immediately, boiling remains the fastest purification method. 1 minute of rolling boil kills virtually all bacteria, viruses, and protozoa. The biosand filter is a medium-term and long-term solution that becomes more effective over time. The flow rate is slow. A properly constructed biosand filter produces approximately 0.4 to 1.0 liters per minute. A family of 4 needs approximately 10 to 15 liters per day for drinking and basic cooking. At minimum flow rates, producing a day's water supply takes 15 to 40 minutes of filtering time. Plan accordingly. Do not allow the sand column to dry out. The biological layer dies when exposed to air for extended periods. Always keep the water level above the top of the sand surface. If the water level drops below the sand, refill immediately and allow the Schmutzdecke to regenerate before relying on the filtered water. And one detail that elevates this from an emergency filter to a permanent off-grid water system. If you add a 4-inch layer of granular activated charcoal between the sand and the gravel, the filter gains the ability to absorb chlorine, some organic chemicals, and compounds that cause taste and odor problems. Activated charcoal is available at pet stores as aquarium filter media for $3 to $5 per pound. A single pound provides months of filtration capacity before needing replacement. Sand plus charcoal plus gravel in a $5 assembly produces water quality comparable to commercial gravity filters, costing $200 to $400. Writings on water purification by sand filtration date to 2000 BC in Sanskrit texts. Ancient Egyptian households used clay vessels filled with sand and gravel to clarify Nile water. The first municipal slow sand filter was constructed in Paisley, Scotland, in 1804. The first slow sand filtration plant in the United States opened in Poughkeepsie, New York in 1872 and operated continuously for 87 years. The modern biosand filter was formalized by Dr. David Manns in 1991 and has been deployed in over 55 countries by organizations including the WHO, UNICEF, and Oxfam. The World Health Organization has stated that slow sand filtration may be not only the cheapest and simplest but also the most efficient method of water treatment. The cheapest, the simplest, the most efficient. Those are not my words. Those are the words of the Global Authority on Public Health. And the water filter industry, which generates $20 billion annually by selling you manufactured products with consumable cartridges, proprietary media, and recurring subscription costs, has never once told you that the technology endorsed by the WHO as the cheapest, simplest, and most efficient water purification method on Earth can be built from 2 buckets, a bag of sand, and a handful of gravel for $2. Because a filter that never needs replacement cartridges does not generate recurring revenue. A filter built from free materials does not generate any revenue at all. And an industry built on selling you water purification as a product cannot survive if you learn that water purification is a process that nature performs for free in every riverbed, every aquifer, and every inch of soil on the planet. But now you know, and the sand is free, and gravity never runs out. That creek behind your neighborhood, that pond at the edge of town, that rainwater collecting in every ditch and gutter and depression during every storm, all of it is drinkable once it passes through 20 inches of sand and a biological layer that nature builds for you in 10 days. If this vault changed how you see the water around you, subscribe and share this video right now. Every share puts this knowledge in front of someone who will be standing next to a river during the next disaster, wondering why nobody told them the answer was beneath their feet. Every subscription keeps this channel digging deeper into the vaults they thought were sealed forever.